Okay, guys, so we are down to the end of the unit. Um, there really hasn't been a lot to talk about in this unit. We've spent a lot of time just interpreting our graphs. Okay, so that's a big focus for our CUA is just interpretations, and then beyond that, right? One of our big things to look at would then be the mean absolute deviation, okay, and maybe the line of best fit. But for the most part, right, our focus is really on interpretation, okay. So when we look at some of these graphs in just a second, all we want to look at is kind of what interpretation can be given or would be given at this graph. Okay, so let's just kind of recap. So unit 5 review. Okay, so very little use of a calculator here. It's all about interpretations. So we have to remember we're talking about the relationship of bivariate data. Okay, so relationships. All right, relationships. There are basically 3 types. And then beyond that, there are 2 subcategories. Okay, so the 3 types are as follows, right? So we have a positive relationship, right? And if we're looking at a graph for a positive relationship, so there's our graph here. Okay, what we're looking for is that there is a trend for the data that goes up, right? So the trend is up, trends up. Okay, that's a positive relationship. The next one would have been a negative relationship. Okay, and just like positive, okay, there is a trend here. Okay, for the negative, it's going to trend right down. We have some data points that might not quite fit the description, and that's okay. But for the most part, the majority trends down. Okay, and then lastly, there is no relationship. Okay, and in no relationship situations, right, we just have random scattered dots everywhere, no rhyme or reason, right? There is no, it is scattered. Okay, so these are our 3 types of relationships that we can determine just visually, right? We just look at it and we can see those relationships. Okay. Now, beyond that, right, we could say linear versus nonlinear. Okay. And as we look at this, again, what we need to remember when it's linear, okay, and this is a great example of a linear relationship, right? This is a great example of a linear relationship. This is nonlinear, okay? They are not in a perfect line. They are in somewhat of a pattern, right? An upward pattern. They don't have to be in a straight line to be linear, okay? So even this one, it is linear for us because it does trend down, right? There is a trend there. Okay, so on top of that, okay, make sure that when you are drawing a line of best fit, okay, when you're drawing a line of best fit, make sure it goes through the middle, okay? That for the most part, we've got some on top, some on bottom, okay? So let's just kind of sketch one out here. Got our graph, got some dots, right, in a row. They're not perfect, right? But there you go, right? So we want to make sure that our line of best fit kind of goes through the middle of the data. So when we envision a line of best fit, when you visualize it, okay, it needs to resemble all of the data. So it needs to track right with that data. So as we draw that line, we want it to cut right through the middle, okay, where there's a sum on top, sum on the bottom, okay, not, you don't connect two dots, right? It needs to follow the trend. You don't just connect the two first and last dots. That would give it a bad trajectory, right? That would have it going this way. We want it to go straight through the middle and kind of follow the trend. All right, that's our line of best fit. And that's going to help us make predictions. So any prediction needs to somewhat resemble or where that line would be. All right. So predictions fall where line would be. Okay. Predictions fall where the line would be. All right. And so the last thing to talk about is really just MAD. Okay. So we've got relationships here. We've got a positive, negative, or no relationship. These are also called correlations. Okay. Just in case we get some other vocabulary coming at us, right? That's a correlation where it goes up, right? Or goes down. Linear is just the dots in a somewhat straight pattern, right? So remember that needs to be a straight pattern, not curved. So this one is curved or scattered. That could be considered non-linear. Okay, curved or scattered are nonlinear graphs. And the last thing again is just that MAD, okay, which is MAD, M-A-D, right? That is mean absolute deviation. And guys, don't make this any harder than it has to be. Okay, so we're gonna just write down the steps, right? Generically, we're gonna find the mean or the average, right? Find the average of the data. 2, right? Find the deviations or differences. And then thirdly, we're going to average the deviations. Okay, that's all we're doing, right? It's just a process of averaging, subtracting, averaging again. Okay, so I'm going to look at a data set here, one of our easier data sets, but going to have it here so we can look at it together. All right, so if you want to pause the video and write those numbers down, maybe even go through the process of finding this, and then we can work it out. So the first thing I need to do is the mean, right? I need to know what the mean is, which is our average. Okay, and all that means is I need to add them all up and divide by the number of numbers. Okay, so add them all up and divide by the number of numbers. So I've got 68 plus 54 plus 73 plus 58 plus 63 plus 72 plus 63 plus 70 plus 61. Okay, so I've got 582. Hopefully that's what you got too. I can't really check. That is my total. Okay, I need to divide that by how many I have. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 data points, right? So 9, divide that by 9. So 582 divided by 9. I've got 64.7. So that's about 64.7. That's my average. Okay, so based on that being my average, I can then find my deviations, right? Deviations. And the deviations again come from, right, each data point, 68 minus 64.7. And then 54 minus 64.7. And yes, you're going to get a negative with this second one, but we don't care, right? We're just going to take the positive. We're taking the absolute value. Okay, so 64.7 minus 68 is 3.3. Okay, so I've got new data set coming. That's 3.3. Okay, 54 minus 64.7. 10.7. Okay. So 10.7, next data set, right? Then I got to keep going. I got to do it again. 73 minus 64.7. I've got 8.3. Okay. And we'll keep going. 58, 64.7. That's 6, 7. 63 is 1.7. 72, that's 8, but subtracting, so 7.3. Okay, 7.3. 63 is 1.7. 70 is 5.3. And 61 is 3.7. Okay. So I've got all of my new data sets. And again, just to double check, did I do it all right? 1, 2, 3, 4, 5, 6, 7, 8, 9. I should have, again, 9 pieces of data because I've got 9 original pieces of data. So I should have 9 variances, right? 9 deviations to then average together again for my MAD, right? MAD is just the average of the deviations, okay? So clearing that out, we got 3.3 plus 10.7 plus 8.3 plus 6.7 plus 1.7 plus 7.3 plus 1.7 plus 5.3 plus 3.7 brings me to 48.7, right? So the mean for this, right, or the averages again, is going to be 48.7 divided by 9. Okay, and which is going to be our MAD, right? That is the answer to this question that we've been asked, right? The MAD is just those values divided by 9, which is 5.4. Okay, so roughly 5.4. That's it, right? That's a MAD. So we get all of our averages. We average the first one. We subtract every value, right, from the average, or vice versa. It doesn't matter. We just make them all positive. And then we average those. And that's our answer. Okay. The MAD is just the average of the deviations. All right. So again, it's telling us on average from this number, 64.7, every value is about 5.5. Okay. About 5.5 from that number. Okay. So if you add 5.5 or subtract 5.5, you should be, most of your data should be in that range. Okay. So that's a MAD. You've got some good practice with that. That was due yesterday. So if you haven't finished that, make sure we get that done. If not, guys, just make sure we look over our notes and make sure that we know the vocabulary, right? What is correlation? What is it positive? What is it negative? What is no correlation? The line of best fit. Do I just connect 2 or do I kind of sketch it through the middle? How do I make a prediction? And then lastly, the process for finding the MAD of a value data set. Okay. So any questions, comments, or concerns, definitely give me a shout on Schoology, and we'll get back with you as quick as we can. Thanks, guys.